Look at this. You already have the question with you. Now please go through that question once. It's an infinite network. This was actually asked was in GATE recent years. Okay. In recent GATE, this question was asked. Now, let us find the equivalent resistance. See, whenever the infinite networks are given, there is a standard procedure. Okay. And remember, you never expect any question in the exam, something like this. 1 ohm, 2 ohm, 3 ohm, 4 ohm, 5 ohm, and so on and so forth. It's impossible to solve that network to anybody, even to me also. Okay. Usually you get these questions in infinite networks. Some kind of repetition will occur in the network 1 1 1 1 1 1 like that, or else 1 2 1 2 1 2 or 2 1 2 3 or 2 1 2 1 2 1 or 1 2 3 1 2 3 like that. Some repetition might be there, or else you get 10 ohm 20 ohm 30 ohm 10 ohm 20 ohm 30 ohm. Some kind of repetition takes place. You understand? Okay. Therefore, you have to observe that. See, the simple concept here is that if you have the resistance, let us say input resistance Rn, okay, here. Now the terminals, whatever the network you are seeing through these two terminals, are you not seeing the same network through these terminals? Say 1 1 1 1 1 1. If I look into the network through these two terminals, I am able to see the same network. Let me draw this 1 ohm here. Yes or no? That means the terminals are getting repeated here. A dash, B dash. I think you see the same network even here also. What is this? A double dash and B double dash. Yes or no? That means even if you calculate the equivalent resistance up to these 2 points by moving in the opposite direction, because we have a common practice, we always come from the rightmost side when we want in the leftmost side. So when you simplify, what is the resistance that you are able to see here? Rin. Yes or no? Now, this Rin, whatever you calculate, it is in parallel with 1 ohm with respect to these 2 points. And that element value, resulting value, is in series with this 1 ohm. Yes or no, all of you? In series with 1 ohm with respect to these 2 points. And that must be equal to what? Rin here. This is a standard procedure. You need to identify the terminals where the network is getting repeated. That is the most important point in this infinite, network models, to find the resistance. Sometimes you might be asking the questions in terms of capacitors or inductors or whatever, but the procedure is standard procedure. Only the formulas are different in the reduction. Okay. Now Rin, up to these 2 points Rin, that is in series with what? Sorry, in parallel with what? 1 ohm. And that result is in series with what? 1 ohm. That must be equal to what? Rin. Now look at this. Rin into 1 by Rin plus 1 plus 1. When you cross multiply here, Rin square plus Rin is equal to Rin plus Rin plus 1. Now you got this Rin square minus Rin minus 1 is equal to 0. You got a quadratic expression. Now you get 2 values for it. Rin is equal to, okay, plus 1 plus or minus root, okay, you have 1 square, okay, yes or no, b square minus 4ac, right, plus minus 4ac, 4 into minus 1 but plus 4 here, and then finally you got 2. So 1 plus or minus root 5 by 2. Obviously you got 2 values, 1 plus root 5 by 2 and 1 minus root 5 by 2. This is a positive value and this is a negative value. This is invalid, but this is valid. Simple. So what is the answer here? 1 plus root 5 by 2 is the answer. What is the standard procedure? Tell me all of you. Whenever the infinite network is given, you have to identify the terminals where the network is getting repeated. Then you automatically get some idea. Understand? Please note down this. And before you note down, just let me explain you once again the alternative approach Okay, in getting this particular relation, you can also observe. Or, because sometimes this approach will also help you a lot. In the next problem, we are going to see that. Look at this. Look at this. Suppose if I calculate the resistance up to these two terminals. For example, if I am able to calculate, that particular value plus 1 will give you what? Rn. So let me try to find this particular value first. Say this is R dash. That means XY terminals, let us call them. Now, if these two are XY terminals, where do you get the repeated terminals here again? Definitely this, X dash and Y dash. That means here also you are going to see the same resistance. What is this? R dash. Even if you see here, you get again R dash. SR2. Now, suppose if I calculate R dash up to these 2 points, this R dash is in series with what? 1. That is in parallel with what? 1. That must be equal to what? R dash. Now you solve for R dash. Once you get R dash value, you add that R dash to 1 to get the value of what? R. This is also correct. So therefore, you can look at this. Okay. R dash is in series with 1. R dash plus 1 parallel with 1 should be equal to what? R dash. That means R dash plus 1 into 1 by R dash plus 1 plus 1. Okay, R dash. Then you have R dash square, okay, plus 2R dash is equal to, what is this? R dash plus 1. Now what do you get here? R dash square plus R dash minus 1 is equal to 0. Yes, sir? Now what do you get? The R dash is equal to minus 1 plus R minus root. Okay, 1 plus 4 by 2. Minus 1 plus R minus root 5 by 2. Again, minus 1 plus root 5 by 2 and minus 1 minus root 5 by 2. Obviously, I can rule out because this is a negative value, but this is a positive value. Therefore, R in value will become what? R dash plus 1. I'm just adding this R dash to this 1 to get this R in. I'm getting, what is that? Minus 1 plus root 5 by 2 plus 1 is nothing but 1 plus root 5 by 2. Okay, so there are two different approaches you can see here. I mean, the logic is same. You are trying to identify the repetition. Okay, why I'm elaborating this, the problem here is because tomorrow you may not get the same question which was already asked in the gate, but you may get the question in different, networks. Okay, there this experience will certainly help you a lot. Okay, so the logic is simple that you need to identify the repetition of the terminals, where the terminals are getting repeated. Because in an infinite network, you need to identify the repeated terminals. Please. Quickly note down. I'll give you time, all of you. Hope you have finished this part. Now, let's come to 18th problem. A slight modification let us try to make in the same problem. Okay. A slight modification. Let's try to make it out. Eighteenth problem. So what is 18th problem here? One ohm, 2 ohm, 2 ohm, 1 ohm, 1 ohm, and so on. Infinity. Find input resistance Rn. Okay, a similar kind of a problem, but with the different numericals here, the different values. Now tell me, how do you solve it? How do you do it? All of you, just make an attempt here quickly. Quickly make an attempt here. Make an attempt quickly. Okay, now look at this. 1, 1, 2, 1, 2, 1 and so on. 1, 1, 2, 1, 2, 1. So whatever the network you are seeing through AB terminals here, you are finding Rn here. Are you able to see the same network here also? Is it possible? No. Yes or no, all of you? Because you are seeing here 1, 1, 2, 1, 2, 1. But you are seeing here what? 2, 1, 2, 1, 2, 1. So 1, 1, 2, 1, 2, 1 is not same as 2, 1, 2, 1, 2, 1. That is why. Now let's go with the other one. Let us keep this particular element aside for a moment. Now hereafter, if you see the network 1, 2, 1, 2, 1, 2. Now what I do is I find the resistance up to these 2 points first, that is x, y. Now definitely these terminals are going to be what? X dash and y dash. Now you are getting the repetition of the terminals hereafter. So same network you are seeing here and here, the same network you are seeing in both the cases. So I can say this is, let us say, R dash. And this is also going to be what? R dash. Now let's find R dash. That R dash plus 1 will give you what? Rn. Let's do that. So what is R dash here? R dash plus 2 parallel with 1 should be equal to what? R dash. R dash plus 2 into 1 by R dash plus 2 plus 1. So what do you get here? R dash square. Okay, plus 3 R dash here is equal to R dash plus 2. So what do you get here? R dash square plus 2 R dash minus 2 is equal to 0. So what is that R dash here now? R dash is equal to minus B minus 2 plus or minus B square, that means 2 square, minus 4 AC, minus of minus plus, but 4 into, okay, AC, that is 2, by, what is this? 2. So minus 2 plus or minus root, this is 8 plus 4, 12 by 2. 4 into 3 you can write, that 4 if you take it outside you are getting what? 2. That's minus 2 plus or minus 2 root 3 by 2. So 2 gets cancelled and you get minus 1 plus or minus root 3. In this, minus 1 plus root 3 and you got minus 1 minus root 3. Definitely is not a feasible value. This is a positive value because root 3 is greater than 1. It is a positive value. Therefore, now R in is going to be R dash plus 1. That 1 is there, right? So therefore, you get what? Root 3 ohm. This is your answer. Understand? But the same problem can also be done in a different way. I told you that there is no unique way in solving the networks, no doubt. But better we see in all different dimensions. So that tomorrow the network is new to us, still we get some ideas with this experience. Okay? Look at this. 1, 1, 2, 1, 2, 1 and so on and so forth you are getting, right? Can I split this 2 ohm into 2? That is 1 and 1 series. Yes or no? I can do that, right? So 1, 1, 1 and 1, right? 1 and 1. Here also 1 and 1. Now you are getting 1, 1, 1, 1, 1, 1. There is one more 1 here. 1, 1, 1. Like what's happening at T network with 1, 1, 1. T network is getting repeated. So if you modify the network, something like this, all of you look at this first. I'll give you time to note down. All of you look at this. What's happening here? 1, 1, 1, 1, 1, 1, 1. Look at this. This is Rn. When this is Rn, where is it going to be Rn once again? These two terminals, right? Yes or no? If this is Rn, then obviously this is also going to be what? Rn. These are the terminals where the network is getting, where network starts repeating. Yes or no? That's it. Now you tell me, up to these two terminals the value is Rn, then that value is in series with 1, then parallel to 1, then series with 1 is equal to what? Rn. So Rn is equal to, tell me, Rn plus 1, that is parallel to 1, and that result is in series with 1. That's it. Now if you simplify this, okay, now if you simplify this, Rin plus 1 by Rin plus 2. Rin plus 1 into 1 by Rin plus 1 plus 1. That's it. This is plus 1. Now you tell me, Rin square plus 2Rin is equal to, what do you get? Rin plus 1, this as it is you are going to keep it, but you are going to get here this one also, plus Rin plus 2, yes or no? Now what do you get here? Okay, you just see here, what's happening? Rin and Rin, this 2Rin get cancelled. Then what do you get? Rin square is equal to what? 3. Then Rin is equal to what? Plus or minus root 3. But you know that this minus doesn't work. Root 3 and minus root 3. There is no negative resistance. Therefore, this is the right answer. That's it. Students, you must be really perfect in the calculation also. Most of the students are missing a good score or not able to score well in the gate because they are doing all silly mistakes in the calculations also. They are good at in the concept. They know the problem, solution, the ways, they are way of solution of the problem, but still they are committing to small mistakes and unable to really get good score in the exam. Ultimately, you have to choose the right answer. Yes or no? Okay. So be careful in the calculation part also. Quickly complete it, all of you. I give a time. Because meanwhile, I will just note down another problem. In your classroom workbook, 19th problem is given, okay? That 19th problem you can see. This was also asked in GATE in the recent year. Very simple one. And this problem was almost, taken by a standard textbook directly and given in the GATE in the recent year. So that's why I keep telling the students always to follow the standard textbook. Sometimes, luckily, whatever the question you practiced, if you get that in the exam, I think you're more fortunate. Yes or no? Hope you have finished this part. Okay, so please look at that 19th question and you also draw it quickly. In the classroom workbook, 19th question, my dear students. It takes more time to draw, but the solution is very simple. One, 1, 1, 1. All are 1 ohms here. All are ohmic values. Then you are expected to find this REB here. Okay. I think it takes more time to draw, but the solution is very simple. Okay. So look at that network. Make an attempt, all of you, quickly. I think you can do it. So look at this. If you observe the whole network, and obviously you know that when you want the resistance this side, you must come from this side. Yes or no? First we will simplify this part, then obviously you are able to simplify all the parts, right? It doesn't take much time because the same networks you are seeing. What is this? Basically 1, 1, 1, 1, and then this is also 1 ohm, okay? This is also 1 ohm. Okay? So even if it doesn't give this 1 ohm or not, I mean, even if it doesn't give this value, you don't worry because this is a balanced width and bridge. Yes or no? So if it is a balanced width and bridge, what is the current that you expect in this element? 0. Current 0 refers to what? Open circuit. Just now we have seen in the previous sessions. When you have a balanced bridge, okay, then you can easily solve it. Otherwise, all elements are neither series nor parallel. When it is a balanced one, there is no need to go for star-data transformation. Directly you get the solution. If it is an unbalanced bridge, you have to go for star-data transformation, I told you, which we are going to discuss in the next upcoming sessions. Okay. So what happens here? This is neglected and the current flowing to this one is 0. So 1, 1 series, 1, 1 series, this 1 plus 1, 2, 1 plus 1, 2, 2 parallel 2, again 1 you are getting. That means this particular section is becoming what? 1 ohm. That means what? This is also 1 ohm, this is also 1 ohm, and this is also 1 ohm. Yes or no? Now, this 1 ohm and this 1 ohm and 1, 1, 1, 1. Again, this is forming a bridge. Look at this. Yes or no? So, what is happening here? Again, this is neglected. And the similar section you are observing here also. The same portion or the same kind of arrangement is available in this particular section also. So 1, 1 and 1, 1, and this is again forming a bridge, width and bridge, and that is a balanced one. You can neglect it. Then what happens here? Tell me. 1 and 1 it is in series. Once you neglect it, and 1 and 1 will be in series. That is 2, 2 parallel to 1 again. That means this entire portion is becoming once again what? Okay, is 1 ohm. If this is 1 ohm, this is also what again here? 1 ohm. Now once again, this is 1, this is 1, again 1 and 1. Again it is forming a Wheatstone bridge. Yes or no? So can you neglect this again? Definitely. So 1 plus 1, 2, 1 plus 1, 2, 2 parallel to 1, 1 plus 1. Therefore, finally, the answer is what actually here? This entire portion is going to be what? Once again, this entire portion is going to be what? 1 ohm. And this 1 ohm plus this 1 ohm, when you add, you're getting what? 2. That's it. That's a very simple problem. Okay, that's why I told you, to draw this network, it takes much time, but to solve the problem, it takes very less time. Okay, so please do it quickly. I think all of you understood this. How do we classify the energy source? There are different ways to classify the energy source. The first classification is ideal, practical. The second classification is okay, independent and dependent. Okay, so let us see now how we actually define them. Classification of energy sources. Energy sources. The first classification is ideal and practical. Ideal and practical. What is an ideal source? Remember, any ideal source, it supplies finite amount of power for infinite time. What is a practical source? It supplies finite amount of power only for finite time. I repeat, it supplies finite power only for infinite time. It supplies finite power for finite time only. Only for finite time. This we already discussed, I think, in the case of active element or passive element. Active element examples also be given. We have given that, ideal voltage source and ideal current source. What is an ideal source? There we clearly described that ideal source will always supply the power continuously for infinite time. Active element is the one which supplies finite power for infinite time. This we already discussed in the earlier sessions. Okay. Now look at this. Let us look at now ideal voltage source, ideal current source, practical voltage source, practical current source, and different, the characteristics also we'll see with respect to the load when they are connected with. Okay. So now I start with the first one, ideal voltage source. Okay. Ideal voltage source will supply finite power for infinite time, that we already know very well. But the internal resistance is 0. What is the representation of the voltage source? There are so many representations, but let me give you a standard one. A DC type source will be represented with V. Okay, simply V. Now, what is a practical voltage source? A practical voltage source is something like this. It supplies finite power only for finite time, and its internal resistance is a smaller value. Its internal resistance is what? A smaller value. Okay? Yes, definitely. When you design the voltage source, you must design the voltage source with the internal resistance as smaller as possible. I'll tell you what is the reason for that. Now look at this. Plus minus V comma smaller. Understand? Okay. V comma smaller. What is smaller here? The smaller refers to what is smaller internal resistance value. But you know that in network analysis, the most important assumption is all elements are ideal. Whether it is a voltage source or current source or resistor, inductor, capacitor. In any given network, before you analyze, you make an assumption that all given elements are ideal. All given elements are assumed to be ideal. You understand all of you? Okay. For that reason, we need to convert this particular element, the practical element, into ideal element. Physically not possible to separate, but it is possible in the mathematical representation, mathematical model, that is, it can be represented with a series model resistor. It can be represented with a series model resistor. Now what does this tell me? Small r is the internal resistance. This is the capital V. Now what does this tell me here, all of you? This particular one is now ideal voltage source. Ideal. But these two together, it is what? Practical. So what is a practical voltage source now? A practical voltage source is nothing but an ideal voltage source with a series resistor. Yes or no? Okay. Practical voltage source is nothing but what? An ideal voltage source with a series resistor. And this is one reason we are trying to keep this resistance value as smaller as possible. Otherwise, what will happen? The voltage, whatever you are having here, the major portion of the voltage will appear, or it may appear across the internal resistance if it is a larger value. If it is not a smaller value, or if it is a larger value, then the voltage major portion will appear here, and the load connected here will experience a low voltage. You understand all of you? Okay, I'll take that case as well. Okay, so first let us look at the consequence, what will happen here once it is. Okay, so let me just give you an example. Yeah, let me keep it as it is. Practical. Now let us look at a simple study that what will happen when, say, this is some 2 ohm. The load, let us say, a motor is connected, 230 volts. All of you carefully observe, don't worry, I'll give you time to note down the things. So don't be in a hurry noting down the things. First, you please focus on it. There are certain points which you need to understand. And interview point of view also is very, very important concepts. Okay, look at this. Load is a motor. Most of the loads are motors, no doubt. Okay, most of the loads are motors. Now, if you take a motor, 230 volts is applied across it, and the motor is, let us say, assuming that it is drawing some 20 amperes. Okay, so what will happen here? If it is drawing 20 amperes, then what is the voltage across this particular element 2 ohm? Tell me. Okay, 20 into 2, it's a 40 volts. Yes or no? Okay. Now, the 40 volts, polarities, how you indicate? Plus minus. How you get the polarities in the case of passive element? It is based on the direction of current through it. It is a passive convention. You call it what? Passive convention. In the case of passive element, okay, if you know the polarities, you can indicate the direction of current. If you know the direction of current, you can indicate the polarities. This is called passive convention. What does it tell about? The passive convention tells that the current in the case of passive element, will enter into positive terminal so that the passive element absorbs power. You understand all of you? Okay. This is called passive convention. I repeat once again. The current will enter into positive terminal in case of passive element so that it absorbs power. Obviously, passive element will absorb power. We already know that very well. Now here, people remember something like this. This is called passive convention, but people remember like this. Current flows from higher potential, lower potential. Therefore, if you have a current direction, you can indicate plus minus. Okay, you remember, it doesn't matter. Okay, finally you must really deal with the problem, properly. That's it. Okay, active convention. What is an active convention? Active convention is very simple. You have a single energy source, let us say, and this voltage source value is positive value. Single source I'm talking about, not multi-source. Again, multi-source scenario is different. We are going to discuss it later. First, let us look at the single source. You have an energy source here, voltage source, let us say. If this is a positive value, then a positive current will leave from positive terminal of the source so that it supplies the power. I hope you understand the point. I repeat once again, what is the active convention here? Active convention says that in the case of active element, if the value V is positive, then the positive current will leave from positive terminal so that that particular element is going to supply the power. Active element supplies the power. Passive element absorbs the power. So with respect to that, the two conventions are defined here, active convention and passive convention. You understand all of you? Okay. We'll come back this once again, but look at this. What is the direction of current? Actually, the motor is drawing here. Therefore, based on this direction of current upward, that means this is plus, this is minus according to this, and 20 into 2, what is this value? 40 volt. Understand? Now, according to KVL, when you apply, this is 230, then what could be the voltage here? 230 minus 40, what is this? 190 volts. That means the motor is experiencing the low voltage problem. You understand? The same scenario you can realize in the case of in a real-time power system. The generator is somewhere located and transmission line, the resistance offered with the transmission line and this is the load which you are operating. Okay, then what is happening here? Now 190 volts the motor is experiencing. That means the motor is experiencing low voltage problem. Usually these low voltage problems arise during the summer. High voltage problems arise during winter. I will also explain you that how high voltage problems are going to come. But low voltage problem is coming here because in summer what will happen? You keep on adding the loads. You keep on adding the loads. You want a fan, you want a cooler, you want a refrigerator, you want a air condition. So many loads you keep on adding. And you need to pump the water from the ground level, and the ground level is a deeper level during the summer, and the motor has to put a lot of effort to consume the power, to pump the water. So much of load is applied on the system, and definitely the load current is very, very high. And because of the load current high, what's happening? The transmission line resistance into that load current will give you what the drop across that resistance is. How much? Let us say, in this case, 40 volt. 230 minus 40 will give you 190. That means the motor is experiencing the low voltage problem. What will happen when the motor is experiencing low voltage problem? What will happen when the motor is experiencing the low voltage problem? See, don't tell me with respect to the speed or with respect to the efficiency, with respect to the, any other. I'm not talking about torque or power or let us say the speed and all those things. I'm not talking about. I'm talking about the safety of the motor. Look at this. To maintain the same power, at low voltage, the motor draws high current. To maintain the same power, at low voltage, the motor draws high current. Then what will happen? I square R dissipation is very high. Then every conductor will have its own thermal limit. The winding in the motor is having its own thermal limit. If that thermal limit is hit by this I square R dissipation, if this is exceeding the thermal limit of the conductor, then what will happen? Thermal breakdown may take place. Once the thermal breakdown may take place, okay, what will happen? The winding is burnt out and damaged completely. Most of the times in summer time, suddenly in our home, the fan suddenly it got stopped. So we immediately call upon the electrician. The electrician will come and check, sir, winding is gone. Why winding is gone? During summer, all the loads are experiencing the low voltage problem, and the loads, particularly in motors, are drawing what? High amount of current. When high current is passing through the winding, I square R dissipation is very high. And because of the high square R dissipation, due to thermal limit of the conductor, if that thermal limit is hit by this heat dissipation, thermal breakdown takes place. And there the winding is gone. Hope you understand. So what do you understand from this? High current may lead to thermal breakdown. Yes or no, all of you? High current may lead to thermal breakdown. That is why during summer holidays, most of the times the windings are gone because of the thermal breakdown, and that is because of the load that we operate. Heavy amount of load will be operated. So there is a huge demand during the summer holidays, and the entire power system is on stress or completely fully loaded or beyond the rated load. Mostly it is overloaded. Okay, so this is how actually. Now coming to the winter, how winter the high voltage problem occurs here. Look at this. The same example I am taking here, 230 volts, and this is 2 ohm, let us say. Assume that there are some 3 motors are operating. Each motor is drawing some 10 amperes. What is the current here totally? According to KCL, totally 30 amperes. What is the voltage across this? 30 into 2, 60 volts. Then what is the voltage between these 2 points? 230 minus 60. What do you get here? 230 minus 60. How much you get? 170. So 170 volts is the voltage which is appearing across the parallel combination of all these elements. 230 minus 60 will give you 170 here. Then definitely all these loads are operating at what? Low voltage. What happens when the motor is operating at low voltage? I square dissipation is very high. Thermal breakdown may take place. Therefore, keeping in mind, what we do is, We adjust the excitation of this particular generator to compensate this voltage. How much here? 60. That means let us now make it 290 volts. 290 minus 60 will give you what actually here? 230 volts. Yes or no? 290 minus 60 will give you what? 230 volts here. Now look at this, all of you. In case if the loads are turned off during the winter, what will happen? After 5 p.m., most of the people will try to turn off the loads. Nobody wants refrigerator, nobody wants AC, nobody wants coolers, fans even. Yes or no? So let us assume that during that 5 p.m. or 6 p.m. you turned off certain loads. Then what is the load that is operating here only? One particular motor, let us say. 10 amperes. 10 into 2, how much here it is now? 20 volts. But already how much you have tuned here? This is now becoming 10 ampere. And 10 into 2, 20 volts. Now 290 minus 20 volts will give you what? 270 volts. Now this is becoming 270 volts. That means the motor is now operating at high voltage. The motor which is in the operation, the load which is in the operation is experiencing the high voltage when the other loads are turned off. What will happen when the load is operating at high voltage? Definitely every load is having some insulation within, and that insulation will have its own breakdown strength. If the high voltage is applied across that insulation, then that insulation may break down. The insulation breakdown may take place. Once the insulation breakdown takes place, then what will happen? The positive and negative terminals will be connected. The bulb is having positive and negative, and in between you have an insulation. If high voltage is operating, that insulation got punctured and plus minus added, then what will happen? It leads to short circuit. Then it is a disaster for the entire system. You understand, all of you? Okay. So high voltage may lead to insulation breakdown. So high current may lead to thermal breakdown. High voltage may lead to what? Insulation breakdown. This is the concept. Okay. So I'll give you the points. First, you please keep note on this. And in the next session, I'll stop here. In the next session, I'll dictate the points also on all these things. Okay. So first, you please keep noting down all these things quickly.